So the cost of work schedule, BCWS, has been calculated as $50,000. Let's now calculate the work performed, BCWP. BCWP basically is calculated as how much of work has been performed. So for activity A, 100% has been performed with 18,000, so it is $18,000. For activity B, only 80% has been done, which is 8K, which is $8,000. So if we can add all these, we get $40,000. So your BCWP is $40,000 and your BCWS is $50,000. Now let's calculate what are the variances. This gives you the story of the entire project. The first thing we're going to calculate is schedule variance. The schedule variance is the budgeted work performed minus the budgeted cost of work scheduled. So your performance is 40,000 and your schedule is 50,000, so you're negative $10,000. And negative $10,000, if it is going to be a negative or a positive, we can find out how the variance is going to be. When you say negative variance, usually that means it's not good. A positive variance is better, okay, or good. And we can confirm this by actually calculating the schedule performance index. These performance index of scheduling gives you a much better way of looking into things, because if it is less than 1, then your cost is high. Okay, so the SPI, the schedule performance index, is going to be equal to the budgeted cost of work performed over budgeted cost of work scheduled, which is 40,000 by 50,000, which is 80% or 0.8. So your costs are actually higher than it is planned. Is it good or bad? Yes, that is bad. Let's look at the cost. Now the cost variance is the budgeted cost of work performed minus the actual cost. The budgeted cost of work performed is 40 and the actual cost is 45. This actually, BCWP, is sometimes also called earned value. Okay, earned value. So earned value minus actual cost is going to be minus 5K. Again, negative means bad in variance. So that means your cost is, you are not performing with respect to cost. The cost performance index, CPI, is the BCWP over AC, and that is 40 by 50K, and that is 0.89. So in general, anything less than 1, like 0.89 or 0.8, anything less than 1 means costs are higher than planned, because you're always comparing it to what is planned. Why? Because you have told your management, this is the budget. The planned money is the budget. So you have told your management that I'm going to finish this project in $1,000. Whether it is going to cost the project 1,200 or 800, that depends on the actual cost. If it is going to be 800, you're doing good. If it is going to be 1,200, you are not doing that well with respect to the project. And that's what it means. So the performance index less than 1 means higher than planned. Performance index equal to 1 means it is exactly as planned. Performance index greater than 1 means costs are lower than planned. So in this case, the costs are higher than planned in this example. The next thing that we want to talk about is network planning models. A project is made up of a sequence of activities. So if you want to construct a room in your basement, the first thing that you want to do is to put up the walls. After that, you're going to put the ceiling. After that, you're going to put the doors and windows. And after that, you're going to put the flooring. So this is a series of activities. And then you're going to construct, you're going to put the electricity and so on and so forth. So this is a sequence of activities that you're going to be performing when you're putting up a small room. So here we need to find out how long it is going to take for you to complete this project. The path taking the longest time through this sequence of activities is called the critical path. The critical path provides a wide range of scheduling information, and the critical path method, called the CPM, helps you to identify the critical path. So you can put the right resources in the critical path so that you can complete the project on time. The critical path method, which is the CPM, identifies each activity to be done, and it also tells you what is the critical path. It also tells you what is the early start for a particular activity, what is the early finish of the particular activity, what is the late start of a particular activity, and the late finish of the particular activity. So you have 4 things that you're going to be considering in a CPM. One is an early start. The next one is an early finish, a late start, and a late finish. These 4 components will tell you how to manage these activities. These 4 components also helps you to put together a network of activities and to determine the critical path. So let's take a look at with an example. Let's say I have a project where I'm going to select a company as one activity, and that activity is called A. And that is the start of the project. So there is no immediate predecessors. That means there is nothing before that. There is no activity before that. So A is where we are starting. So this is my project A, or the activity A. The second activity is obtaining the annual report and performing ratio analysis. That is going to be designated as B. In order to do B, I should have completed A. If A takes 1 week, B takes 2 weeks after that. So after the first week only I can start my B. That's how we are going to look at it from a precedence relationship. C, on the other hand, collecting stock prices and performing technical analysis, is going to take 1 week, but that is also done after A. So B and C can be done only after completing A. And D can be done only after completing B and C. And D will take 1 more week. So if you can take this, you can say 1 plus 2, which is 3 plus 1, 4 plus 1, 5 weeks. It is going to take 5 weeks. Let's look at it from a network, how long it will take, how long this project will take. So every activity, as I said, has got an early start, an early finish, a late start, and a late finish. So I'm going to determine those first. I'm going to start with 0 as my early start for A. Since A will take 1 week, it is going to be 1 as my early finish. My early finish is going to be the early start for the next activity, both this activity as well as this activity. B is going to take 2 weeks, so 1 plus 2 is 3 weeks. So at the third week, I'll be completing my B. C is going to take 1 week, so 1 plus 1 is 2. So this is going to take 2 weeks to complete. My early finish of B is going to be my early start of D. I'm going to determine this as what is the maximum. I'm going to find the maximum of these two because these two are merging to become the next activity. When I have a merging, when two tasks are merging to become the next activity, I'm going to find the maximum time and I'm going to use that maximum time as my early start, and that is going to be 3. And so it is going to take 4 weeks now. So this project will be completed in 4 weeks. Whereas if I just calculate the time taken, it's going to take 5 weeks. Why is it 4 weeks? Why is it not 5 weeks? The reason is I'm doing these two in parallel. I'm not doing, whereas here I'm doing everything one after another. But actually these two are parallel. I can do these two. As soon as I finish here, I can start these two if I have enough resources, right? So, and I have enough money and all that. So, which I'm thinking I have. So, instead of 5, I can do this in 4 weeks. Okay? And I can do, this is called forward chain. I can do a backward chain to get my late start and a late finish. And that backward chain will tell me or confirm me whether I can finish this in 4 weeks. Okay? And this is how you do a network analysis. So let's take this example. I have to design, prototype, evaluate, test the prototype, and then write the reports, and that is my entire project. So I have various activities, and I have various predecessors, and the time it is going to take for each activity. So A is going to take 21 weeks. C can be done after A, and it is going to take 7 weeks. B can be done after A, and it is going to take 5 weeks. Okay? D can be done after finishing B, and it is going to take 2 weeks. F can be done after completing C and D, and it is going to take 8 weeks. E can be done after completing C and D, and it is going to take E weeks and 5 weeks. And that is denoted here. G, on the other hand, I have to complete F and G, then only I can do G, as this one says here. And that is going to take 2 weeks. So I have now put the network diagram, which is also called the precedence diagram. Now I'm going to find the critical path. How do I find the critical path? I'm going to find for each task, I'm going to find the early start, early finish, the late start, late finish. And then I'm going to take the early start and the early finishes and confirm that it is going to take 38 days to complete this project. Okay? How do I find the critical path? The critical path is found if I'm going to take the early start minus the late start, or the early finish minus the late finish. If that is going to be equal to 0, I'm going to take that as a critical path. So between A and B and C, between A and C, I have 21 minus 21, 28 minus 28, 0. 26 minus 26 is 0. 21 minus 21 is 0. How do I do that?